video, you're going to see the answers to station 1. Let's begin with number 1. The first thing you want to do here is you want to collect like terms. So I'm going to look at the left side, and I'm going to see that on the left side there are no like terms to collect. On the right side we have 1p, 3p, and a negative 2p. So I take 1 plus 3 and I subtract 2. Well, this becomes 4, and 4 minus 2 is just 2. So we have 2p on the right side, and on the left side we have 4p minus 10. Now that we've collected like terms on the left side, we've collected like terms on the right side, we're ready to put all the variables on one side and all the constants on the other. So we're going to move this 4p over to the right side. We want our variables on the right side, our constants on the left side. That's going to be the fastest move you can make. So 4p minus p, 4p, is going to leave you with a negative 10. And then on the right side, 2 minus 4 is going to give you a negative 2p. So we're just using inverse operations to move that variable to the other side. Now we need to get p alone, and the negative 2 is keeping the p from being alone. The operation is multiplication. The inverse of that is division, so we divide each side by a negative 2. Over here, that cancels, we get 1p, and on the left side, we get 5. So p equals 5. Number 2. Again, we start by collecting like terms. We have like terms on the right side. Negative 8 plus 1, that's 1w. We get negative 7w. On the left side, there are no like terms to collect. Negative 36 and 2w are not like terms. So now we're at the step where we want to put all the variables on one side and all the constants on the other. Since this variable is on the right side and we have a constant on this side, the fastest way to complete this problem is to move this 2w to the right side. We're going to use the inverse operation to do that so that we get 0 when we take 2w and subtract 2w. We'll be left with negative 36 on the left side, and on the right side, negative 7w minus 2w is a negative 9w. The final step here is to divide by negative 9. The operation was negative 9 multiplied by w, so the inverse of that is division. We cancel that on this side, that equals 1w. On the left side, negative 36 divided by negative 9 equals 4. So w equals 4. Number 3. When you look at this, you can see that there are no like terms on the left side. There are no like terms on the right side. So now we can move straight to the step where we put the variables on one side and the constants on the other. Doesn't matter which side you put the variables on, so in this situation I'm going to put the variables on the right side, the constants on the left. You could have done it the opposite way. I'm going to start by moving this variable to the right side, and I do that by subtracting 5x. That's the inverse of a positive 5x. Whatever you do to one side, you have to do to the other. So 5x minus 5x equals 0. We're left with negative 14 on the left side. On the right side, we get negative 5. 8 minus 5 gives you a positive 3x. Now, on this variable side, we have a constant. We don't want a constant on the variable side. We want to move it to the constant side. So the opposite of minus 5 or subtracting 5 is adding 5. So we're going to add 5 to both sides to maintain equality. Over here, negative 5 plus 5 equals 0. So we're left with just the positive 3x. And then on this left side, negative 14 plus 5 is a negative 9. The 3 is keeping the x from being alone. 3 is being multiplied by x. So the inverse of multiplication is division. We divide each side by the number that is keeping x from being alone. Negative 9 divided by 3, we get a negative 3. X equals negative 3. Next problem. Number 4. Again, there's nothing to collect. So we're going to go ahead and move all the variables to one side and all the constants to the other side. This time I'm going to put the variables on the left, the constants on the right. I'm I'm going to start by moving this 8x because the 8x should not be on the constant side. So we want to move it over to the other side. So this is a positive 8x. I use the inverse operation to move it to the other side. Whatever you do to one side, you must do to the other. 8x minus 8x equals 0, so we're left with 7 on this side. On the other side of the equal sign, 2x minus 8x is a negative 6x. And now I need to move this constant to the constant side. So the opposite of subtracting 5 is adding 5. Whatever you do to one side, you must do to the other. Negative 5 plus 5, that's 0, equal to 0, so you're left with negative 6x. On the right side, 7 plus 5, we get 12. And then the final step is to divide each side by a negative 6. Because that's the inverse of multiplication. So x equals a negative 2. All right, next problem. Number 5. We look at it and we see if there are any like terms to collect on the left or right side. And there are like terms to collect on the left side. We have 1/4 plus 1x. Now some of you will already know that that is equal to 1 and 1/4 x. But if you'd rather look at this like we have been in class to review, you need to change the 1 so that it has a denominator of 4. So I'm going to do that work over here. 1 over 1 needs to be something over 4. Well, we take 1 times 4 to get the 4. So that means we also need to multiply the numerator by 4 to get 4. So 4 over 4 is equivalent to 1. So I just replaced 1 with 4 over 4 so that we have the same denominator here. 1/4 x plus 4/4 x equals 5/4 x. And on the other side, you just copy it down. Five-fourths is the same as 1 and 1/4. On the right side, there are no like terms to collect. So now we need to move the variables to one side and the constants to the other. So the constants I'm going to put on the right side, the variables on the left side. So I'm going to subtract this 1/2 x using the inverse operation to cancel. On the right side, I'm going to be left with a negative 3 because 1/2 x minus 1/2 x equals 0. And then whatever you do to one side, you must do to the other. Now, remember, when we're subtracting with fractions, the denominators need to be the same. So here's our problem. I'm going to write it over here. 5/4 minus 1/2. Well, I need to change this 1/2 so that it has the same denominator as the 5/4. So the 5/4 I don't need to change, but this 1/2 I need to have with the denominator of 4. 2 times 2 gives you the 4. So we also multiply the 1 by a 2 to get 2. So negative 1/2 also equals negative 2/4. So let's try this again. 5/4 x minus 2/4 x is equal to 3/4 x. Now on the other side, we're left with that negative 3. In class, we've been using reciprocals in a situation like this. So we're going to multiply the left side by the reciprocal because the 3/4 is what we want to get rid of. The 3/4 is what is keeping the x from being alone. 4 times 3 is 12, 3 times 4 is 12, so we get 12 over 12x equals, and on this side we must also multiply by 4/3. I wrote negative 3 as a fraction since we're multiplying negative 3 by a fraction. Negative 3 times 4 gives you negative 12. 1 times 3 gives you 3. On the left side, 12 divided by 12 equals 1, so we're left with 1x. On the right side, negative 12 divided by 3 is negative 4, so x equals negative 4. And that was problem number 5. So we're finished with station 1.